Identify components of turbine engines. At 35,000 feet, there's no room for error. Identifying turbine engine components helps technicians troubleshoot issues and ensure aircraft readiness. Let's walk through the 4 major components of a turbine engine and their subcomponents that make each section function with precision. Let's start with the intake. Air enters the intake. The shape of the inlet reduces turbulence and ensures smooth airflow into the engine. Some designs include inlet guide vanes to better direct airflow. From here, the air flows directly into the compressor. The compressor increases air pressure before combustion, allowing for efficient fuel burn. Primarily, there are 2 types of compressors, centrifugal and axial. In a centrifugal compressor, air enters the center of a spinning impeller and is flung outward through a diffuser. In contrast, an axial compressor uses multiple rows of rotor blades and stator vanes to compress air in stages. These are more efficient and used in high-performance engines. Now let's move on to the combustion system. Inside the combustion liner, compressed air is mixed with fuel and ignited. The key components of a combustion system are as follows. Fuel is delivered through fuel nozzles, which are of 2 types, simplex or duplex. Igniter plugs, usually 2 per engine, provide the initial spark for combustion. At the bottom of the system, drain valves help prevent fuel from pooling. This entire system, enclosed in flame tubes or liners that protect the outer casing from intense heat, is called a combustion chambers. The common types of combustion chambers are can, annular, and canannular. Can-type systems have separate liners for each burner and are easy to service. Annular chambers use a single, ring-shaped liner and are compact and efficient. Canannular chambers combine the features of both, offering both serviceability and performance. Next comes the turbine and exhaust system. Let's start with key components of a turbine and exhaust system. Hot gases flow through the turbine inlet guide vanes, then spin turbine blades and discs that drive the compressor and accessories. Next, the gases strike the turbine discs and blades. Exhaust gases then exit through the exhaust nozzle, providing additional thrust. The turbine has 3 variants: turboprop, turboshaft, and turbofan. Turboprop drives a propeller via a gearbox. Turboshaft transfers power to rotors, for example in helicopters. Turbofan moves bypass air for quieter, more efficient thrust. Finally, let's talk about the accessory and support systems. The accessory gearbox drives fuel pumps, oil pumps, and electrical components. Just as important are the bearings and seals. Bearings keep rotating parts aligned. Seals prevent oil leaks and maintain lubrication. Every turbine engine is a system of moving parts with a single purpose, powering flight with precision.